Welcome to MathSolve. In this lesson, we are going to learn how to find out LCM and HCF using prime factorization. LCM stands for least common multiples and HCF stands for highest common factor, and sometimes it's known as the greatest common factor, which is GCF. What does LCM mean? If we start with an example, so if the question asks to do the least common multiples of 12 and 16, then what does it mean? So we are trying to give the idea what is least common multiples, what is highest common factor. Then I will try to show you how to find out this. It doesn't matter it's 3 numbers given or 4 numbers given. I will give you a method that can be useful for, doesn't matter how big the number is or how many numbers is given to and asking for common multiples or common factor. That's what I am choosing this technique to explain the students. So first, what is least common multiple and why we need the least common multiples? Least common multiples terms we often use when we are doing algebraic or like arithmetic fractional addition and subtraction. And when I explain the fractional additions, I always mention that we have to make it least common multiples in the denominator. So how to find out that least common multiples? So first, if we start with the 12, as I said, we have to find out the least common multiples of 12 and 16. What is the multiples of 12? That's the question. What is the multiples of 12? Multiples of 12 is 12 because we are multiplying actually by 1, then multiplying by 2, multiplying by 3. That's how you are getting the multiples. So if you get the multiples of 12, which is 12, then 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 12 times 5, which is 60, so on, never ending. It just go on. Then for 16, you can go 16 times 1, which is 16, 16 times 2 is 32, 16 times 3, which is 48, 16 times 4 is 64, and so on. But we are talking about the least common multiples. So when we are going for multiples, it's just coming as like a big numbers, and the same way is coming here. So, but you can see least common. So where is the common thing is happening for the lowest number, not the, maybe they are matching somewhere here as well, but we are not interested for the highest value. We are looking for the least common multiples. So these are the multiples where they are common. So you can see that 48 and here is a 48, but before that there is nothing matching here. So only that 48 is matching with that 48, but maybe after some time again they are matching, but this is the least number that they match. So that's why it's calling least common multiples. So how to get the least common multiples? First we are getting the multiples of 12s, we are getting the multiples of 16, then we are checking where the minimum number they are matching with each other. That's called least common multiples. So if I just write this is the least common multiple of, so I can write down the 48 is least common multiple of 12 and 16. Okay, but now what is the highest common factor for these two numbers? So highest common factor, first you have to understand what is the factor. Factor means the number that can divide this number. So it means like if I have a 12, so what are the numbers that can divide 12? 1 can divide 12, so 1 is the factor of 12. 2 can divide 12, so 2 is the factor of 12. 3 can divide 12. 3 times 4 is 12, so 3 you can divide 12 by 3. You can divide 12 by 4. You can divide 12 by 5, no, 12 by 6, yes. Then you can't divide by 7, 8, 9, 10, 11, only you can divide by 12, the number itself. So 1 and 12, the number itself, you can divide any number, you can divide by itself and divide by 1. Okay, and these all are called the factor of 12s. Okay, so these are called multiples of 12, these are called multiples of 12, multiples of 16, and these are called Factors of 12. What is the factors of 16? 1. You can divide 16 by 1. Yes. You can divide by 2. You can divide by 3. No. You can divide by 4. 4 times 4 is 16. Yeah. And then you cannot divide by 5, 6, 7. No. 8. You can divide by 8. Yes. And then you can only divide by 16. You see, that stopped here. So that's a good thing. Like here you can go like infinite, like big numbers, but here it's just stopping after some time with the number itself. Yeah. Now these are the factors. The question is highest common factor. So where is the highest common factor? So if you look at the common thing, where is the common? 2 common. Okay. So this is common factor. That's true. It's a common factor. Okay. Then 4 common. This is also common factor. Then you have 8. No. 16. No. So it means we have 2 common factor. 2, 4. But we are talking about the highest common factor. Then we have to go for 4. So it means 4 is the I can just say LC. If I just, instead of writing whole one, I can just write down is a HCF of 12 and 16. So when I'm talking about the least common multiples, first we are doing the multiples and then checking where the least value they are matching. When we are checking the highest common factor, first we are doing the factorizing, like we are trying to get the factors of that number, and then where is the maximum factor matching or common, not the minimum one. Okay, that's why it's called highest common factor. And this highest common factor is only used when we are doing the factorizing of algebraic expressions. And these multiples we are using mostly when we are doing the fractional addition and subtraction. Now, the problem of this method is when you are given like a 3 or 4 numbers and asking for find out the least common multiples, then it's like you have to do lots of work. And if it's a big numbers and you never know where they are matching, maybe you have to go up to 7, 8 numbers for each, which is time consuming. And at the same time you have to find out like if the question asking HCF as well, then you have to do the factorizing for all these and find out where they are matching. Okay, in order to save time, and also you can deal any sort of number like 3 or 4 number, doesn't matter, and how big the numbers are given doesn't matter. You can use a method that really makes it easy. That's called prime factorization. So now I am showing the same problem by using prime factorization.